Okay, so in magnetic field, the definition is very similar like the electric field. All practice this in your life that when you place magnet, and if you place some thumb pins or some common pins at a very short distance from the magnet, so magnet automatically attract those pins from some distance also, because there is magnetic field around that magnet. Or like we also know that when we bring magnet close to the TV screen, so it will also change the color from that specific area, because magnetic field will disturb the electromagnetic field inside the uh, that TV or that screen. So these all are the concepts related to the magnetic field. So we will define it as a region in space around a magnetic field, around a magnet and other magnet, or a magnetic material experiences a magnetic field. So this is the definition for the magnetic field. Very simple. Again, there is a region, and simply it means if you place magnet, so we consider magnet, and in this magnet, one side will be north and second side will be south. Okay, one question before marking the magnetic field. Let's suppose if we consider that half part of the magnet is north pole and half part of the magnet is south pole. If I
Right.
just break this magnet from the middle, from this purple line, so what happens after that magnet breaks into two pieces? So is there still north pole or south pole, or only north pole one on one side and south pole on the other side? If we just break the
North
magnet
Pole,
into
South
two.
Pole, North Pole,
North Pole, South
North
Pole.
Pole, South Pole.
Yes. So always remember, if you break the magnet into two parts or more than two parts, so still each part consists of north and south pole, right? Like if I break this magnet from the middle, so you will get north and south pole on each piece of the magnet. So this is one more important thing related to the magnet. And for the field lines will flow from north to south. So you have to draw the field lines like this. Arrow is very important because the direction will be represented by these arrows. So magnetic field is moving from north to south, right? It is like outwards from the north and inwards from the south. And one more important thing, last time we discussed that we have to make the field lines at increasing distance, right? Because as far as we move away from magnet, so definitely magnetic field starts to decrease, right? So we have to make magnetic like this. So you can see there is increasing distance between the field lines. So from north it will always outside, and from south it will be towards the pole, like this. So this will be the magnetic field lines for the magnet. So I will mention again the important points in the diagram, that this increasing gap show you. So increase in gap to show decrease in magnetic field. So when you find out the distance between, or when you observe the distance between the field lines, so you observe that your distance is increasing as compared to the previous distance. So it means your field lines is now uh, or the magnetic field is now decreasing at a long distance. And secondly, if we consider this side from the north, so field lines are coming out the north. So field lines emerge out of north. So that's why you observe that the direction of the arrows are outward. And if you consider the south side, so from the south side field lines are enter into south. Any confusion in this idea?
No, sir.
Okay. And again, we know if we place north and north, so they will repel. If we place north south, so they will attract. And which component or which device will help you to identify the direction of magnetic field? If you know about, or if you know the name of that component, that will help you to identify the direction of
Compass.
magnetic field. Compass, right? Okay. So these are like very common things. We all know about these things because we already use the magnets and compass in our daily life, and also observe in many videos and voice. Okay, so if we consider some questions related to the current, electricity, practical, electromagnetism, induction. Okay, okay, we have questions related to electromagnetism. These are the questions to electromagnetism, and if we consider only for magnetism, this is also related to induction. Just a second. Okay, so for magnetism, These are from the basic concept of the magnetism. Let's consider some questions. Which statement about a magnet is correct?
B.
A magnet does not attract a plastic rod, right? So basically this is very simple. And what about question number?
C.
C? Okay.
Yeah, it's C.
Okay. So basically in this question, if any one of you have any confusion, you may ask again. Basically in this, a student wishes to make a permanent magnet. So this is your important term, permanent magnet. And she has an iron rod and a steel rod. And you already know about these names because we already discussed these concepts, that iron will be converted into temporary and steel will be converted into permanent magnet, right? So we have to use steel, and steel is hard type of magnetic material. So definitely it will be C. Okay, question number so we have two nickel bars and they are placed close to the north pole of a bar magnet, and the nickel bar becomes magnetized, right? So it is clearly mentioned it becomes magnetized, so you don't need to think about that it will magnetize or not. It is clearly mentioned. And which row states the pole induced at P, the pole induced at Q, and the type of magnetic force between P and Q?
A.
A.
Okay, option. So this will be north, again this will be south, this will be north and attraction.
Yes,
Because
option A.
yes, initially we are using a nickel and that becomes magnetized. It means initially it is not a magnet. So when it becomes magnetized, so it will attract towards it. So north south, again there will be a force of attraction because we have unlike poles together. Okay, correct. This is the same. About question number 5.
B.
B. Okay. So they are asking which statement about magnetism is correct. So they are asking about magnetism. So you mentioned an unmagnetized steel bar can be magnetized by passing a current through it, right? So basically, we discussed about this concept in the notes. Okay, option A. I got one another answer, which is option A. So it discussed about moving charge. So moving charges means electric current. When charge starts to move, so definitely they will produce electric current. So this is the one thing. And in option A, it is mentioned an unmagnetized iron bar becomes magnetized when it is placed near a magnet. Okay, so this is another option. Any other one wants to mention any other reason for this?
No, I don't think so.
Okay. And in option C, it is given that the direction of magnetic field line is from south to north pole. So that is not possible because it will always from north to south as we mentioned in the diagram. So it is not possible to move from south to north. And the last option is the north pole of two magnets, and this is also not possible. So either option A, either option B. So basically, it is written an unmagnetized steel bar can be magnetized by passing a current through it. And first is by placing it near a magnet. So in this option, this is option A because they are asking about which statement about magnetism is correct, right? If they ask how to magnetize, right? So basically,
Oh,
yes. So there is only a difference of the term. They are only asking about basic magnetism, right? If they ask how to magnetize, so in that scenario, you will mark option B. Basically, both statements are like the right one, but there is only the difference of the question they ask about magnetism only. So about magnetism, if unmagnetized iron bar become magnetized when it is placed near a magnet. So this shows you the property of magnetism. Okay, question 6 is also easy. Which pair both materials are magnetic?
C.
Iron and steel.
Yeah, same. Yeah, option C.
Because in this chapter, you will find many easy questions. Okay, mostly of you discussed about and all of you studied about the electric field, right? We will discuss about magnetic field also. If I just, yes. So last time we discussed this concept of the field lines when two same poles of the charge and the same unlike charges are placed close to each other. So when we place same charges close to each other like positive positive, so they will make field like this because of repulsion. So same copy paste concept you have to use for magnets. Like if we place north and north on the place of this positive sign, so definitely this will be the field line for the magnetic poles, right? Because north will always flow from uh, in outward direction. So they will also make the same pattern, right? And if we consider north and south pole like unlike poles, so they will make the diagram the same field lines in diagram number 2 because they will attract each other. So if you consider the question and if you consider the field lines, so the field lines are moving in outward direction. Okay, so these outward directions are for north or south.
It's C.
It's
It's
C.
for North.
Yes, so from that concept
Oh,
you can easily relate that concept with the magnet because field lines are moving out and you know north pole makes the field to move in outward direction, so definitely it will be north. And on the other side fields are moving inside, so definitely this side will be the south pole. Okay, option C. So these are some basic questions related to the magnetism, and in this chapter we discussed about the field, and next time we will continue basically the concept of the poles like poles and unlike poles you already get over here, just like the charges, so you don't need to make again and again the same diagram. And inshallah next class we will discuss the earth's magnetic field, that is also a very short topic, and we will discuss some theoretical questions of electrostatic plus magnetism, and that will be the end of the magnetic chapter also because only magnetism is very short, electromagnetism is very detailed topic. So these are two different things. In magnetism we only talk about magnet, but in electromagnetism there are different examples of mechanism plus electricity plus magnetic field. So that's why that topic is the detailed one. Okay, so magnetism chapter is also completed almost 90%. Okay, we will discuss the concept of the earth's magnetic field, plus we discuss about uh, the questions related to the magnetism in theory also, right? So in next class we will start with earth's magnetic field.